Hello students, in this video we are going to be looking at applications of unit rates. Application is just another word for word problems. Don't let it intimidate you though, these are not terribly difficult. So we have already done a few little problems looking at unit rate and figuring out what unit rate is, and if you remember, it really just involves, most of the time, it just involves dividing one number by the other. Whether you get a whole number or a fraction or decimal, doesn't matter. That's still the unit rate. And if you remember, unit rate is the rate, or a lot of times it's the price for one unit, whether the unit is ounces or pounds, or you might be talking about how many miles per gallon. So those are all unit rates, just as a little review of what we talked about so far. So let's talk about the steps to finding a unit rate and solving an application problem. The first thing we want to do is in math, anytime you're trying to solve a problem in math, you want to use what you've been given. So use what you know to find the unit rate. And then number two, write an equivalent rate so that it matches the scenario. Now the scenario would be the word problem itself. So whatever your scenario is, you need to use your unit rate and then take the rest of that information and solve the problem. I'm going to show you, I'm giving you the steps, but when I show you the problems, it's a whole lot easier than reading the steps. This first problem, it says Diana prepared 28 kilograms of dough after working 7 hours. So she prepared 28 kilograms in 7 hours. All right. If we were just doing unit rate, if it was asking how many kilograms would she prepare in 1 hour, then all we would be doing is dividing 28 by 7. That's not what it's asking though. I want you to look at what it's asking. It's asking how much dough did she prepare if she worked 11 hours. Okay, and then assume the relationship is directly proportional. In other words, it's going to make a straight line on a graph. So let's look at the first set of information that we've been given, the 28 kilograms of dough, 7 hours. So if she can make 28 kilograms in 7 hours, and that is a ratio, okay? A ratio is just a fraction. We can write this in a couple of different ways. We could write 28 to 7 like that, but I usually write it in a fraction. It's easier to solve. And to find the unit rate of this, what I want is how many kilograms of dough. So my kilograms are on top, kilograms are in the numerator. I'm going to just name that N. How many kilograms could she make in 1 hour? Okay, so what I want is I want to create an equivalent fraction right here. So I need to know what the N is. I need to know what is the unit rate. How many can she prepare in 1 hour? So I'm going to look at what I've been given, my 7 and my 1 I've got down here. What do I do to 7 to get 1? Well, I divide it by 7. So in order to get an equivalent fraction here, I need to also divide the numerator by 7. So that would mean that N would equal 8. So my unit rate is 8. Well, that's not what they're asking me for, but it's helpful usually to find the unit rate first. Okay, so if she can prepare 8 kilograms, so we'll say 8 kilograms in 1 hour, okay? How many can she prepare if she works 11 hours? So what I'm going to do is I'm going to set up another fraction here. So if she can prepare 8 kilograms in 1 hour, how many kilograms is that? In other words, I've got an N right here again in 11 hours. Okay, so now I can just do another equivalent fraction. We'll talk about solving these proportions later, but that's actually in a later video. So what do I do to 1 to get 11? Because the denominators are what I've been given. I don't have both numerators, so I can't really work with those. I can work with the denominators though. What do I do to 1 to get 11? Well, I multiply it times 11. Well, if I multiply times 11 in the denominator and in the numerator, I'll have an equivalent fraction. So 8 times 11 is 88. That means N equals 88. So that is my answer. She can prepare 88 kilograms of dough in 11 hours. So we used the unit rate, found the unit rate, and then really you're just multiplying it times the number of hours, but I just wanted to show you that sometimes you'll want to look at an equivalent fraction like this. Problem where we can use unit rate to solve and answer the question that they're asking. Rachel grew 276 plants with 92 seed packets. How many seed packets does Rachel need to have a total of 300 plants in her backyard? The relationship is directly proportional. All right, so let's figure out how many plants she can plant with one seed packet. So if she can plant 276 with 92 seed packets, all I really have to do is divide 276 divided by 92, and that's my unit rate. And what I get is 3. You could set up a proportion where you have n over 1 or whatever. That's fine, but typically we're just going to be dividing one number by the other. So my unit rate is 3 plants per seed packet. Okay, so if she can plant 3 plants per seed packet, and she wants to have 300 plants in her backyard, let's talk about this. Okay, so if I want to have if I can plant 3 plants per one seed packet, I'll abbreviate that. Look at what they're asking us. They're asking us about 300 plants, not the number of seed packets. So when we do this fraction over here, what we want to do is we want to make sure that we have plants in the numerator. Anytime you set up something like this, you want to make sure both fractions have the same unit or the same type of item in the numerator and the same item in the denominator. Okay, so we're asking about how many seed packets. So that's what we don't know. We don't know the number of seed packets. So we're going to name that n. Then we will put the 300 here. What we're saying is if Rachel can plant 3 plants with one seed packet and she wants 300 plants, how many seed packets does she need? So then what we'll do is we'll look at the numerators because that's what we've been given. All right, so what do I have to do to a 3 to get 300? Well, I'm going to multiply it times 100. And then I do the same thing in the denominator because I want an equivalent fraction. 1 times 100 is 100. So n would equal 100 packets. And they just want the number up here, so we'll put a 100 here. So it would take 100 seed packets to have 300 plants. All right, let's look at a different type of problem. If you watched my unit rate video, you would have seen this exact same problem. This is what we call a better buy. Okay, so which or a best buy. There's a store called Best Buy. So what we're asking is which is the better buy? Is the cranberry juice a better buy or the orange juice? And that, you know, they could be exactly the same type of juice in different size containers. And what you want to be able to do is figure out which one should I get if I don't mind buying a little bit more. Is that a better deal? Okay, so which one is the best deal? So let's look at this again. We looked at it in the unit rate video. I'm going to look at it really quickly. So we see we have some cranberry juice here, and it's $5.28. And then we have some orange juice, and it's $2.98. So at first glance, $2.98 is less than $5.28. So it looks like the orange juice is a better deal. But when we look more closely, get my highlighter here. What we see is that this one is 5.2 cents per ounce, and this one is 5.7 cents per ounce. So actually the better buy is the cranberry juice because it's 101, a little over 101 fluid ounces. The orange juice is only 52 fluid ounces. So even though the cranberry juice costs more for the bottle, it is a better buy because it is less per ounce, and that is the unit rate. So the unit rate for this cranberry juice is 5.2. The unit rate for the orange juice is 5.7. Now let's do an actual problem where we have to compare two things and figure out which one is the better buy. I do this all the time in the grocery store. In the grocery store, though, now a lot of them they actually list the price, the unit price for you. So that makes it a lot easier. Okay, so let's look at this problem. And this is the last one we're going to do on this video. Which one is the better buy? We have over here on the left a 16-ounce jar of jelly, costs $2.16. And a 24-ounce jar of jelly costs $2.88. Again, at first glance, $2.16 is less than $2.88. But let's figure out the unit rates. So what we want to do is we want to find the unit rate for each item and then figure out which one has a better unit rate. So what I'm going to do is I'm going to take the amount that this jar of jelly costs, $2.16, and I'm going to divide it by the number of ounces. And this one over here, I'm going to take the $2.88 and divide that by 24 ounces. So I have my price in the numerator. I have my ounces in the denominator. Over here, price, ounces. And I'm just going to do the math here. I'm just going to divide $2.16 divided by 16. And you can put that in your calculator. And I get, so what I get is 0.135. But remember, this is money. So this is actually 13.5 cents per ounce. All right, let's look at this one. 288 divided by 24, I get 0.12. Well, that is 12 cents per ounce. Okay, so which one has the better unit rate? Well, 12 cents is less than 13.5 cents. So what that means is that as long as I don't mind buying a bigger jar of jelly, this one has a better unit rate. So I would buy this one because I know we're going to go through it in my family. So I would buy the bigger jar of jelly because it is less per ounce than the smaller jar. All right, so that's it for that topic. The next thing we're going to do is graphing proportional relationships. So that'll be our next video.